Unit 4 Geometry test review. In this first question, the equilateral triangle has a side length of 8 units. What's its height? So if it's an equilateral triangle, it means all the sides are the 8 units, and we're looking for the height, which is going to be perpendicular. Equilateral triangles have 60-degree angles, which means that right here we will have a 30-degree angle. This is technically a 30, 60, 90 special triangle. So knowing that, we know that if the hypotenuse is 8 units, then the short side is going to be 4, and the long side is going to be 4 square root of 3 units. With our trig ratios, we have sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So in this triangle, just going through each of these, sine of 27 is equal to x over 15. That's not true because x is the adjacent side. Cosine of 63, so looking at this angle, is equal to y over 15. That is true because y is the adjacent side to 63 and 15 is the hypotenuse. Tangent of 27 is equal to y over x. That is true because that is opposite over adjacent to 27. Sine of 63 is equal to x over 15. That's true because x is the opposite, 15 is the hypotenuse. And tangent of 63 is equal to y over x. That is not true because if we have tangent of 63, it would have to be x over y since that's the opposite over the adjacent. Based on this figure, which equation is true? So sine of 32 degrees is equal to 8.5 divided by x. That is true. And then obviously sine of 32 is already 8.5 over x, so it can't be x over 8.5. Then cosine of 32 has to be adjacent, which does not have a label, so that means that A is the only correct one. Solving for y in this case, we have the angle 63, and then y is opposite to that, and 6 is the hypotenuse. So we would have to use sine of 65 is equal to y over 6. Let me just pull up my calculator. If we multiply both sides by 6 to get y by itself, we'll get 6 is equal to 6 times the sine of 65 equals y. And if we type that into a calculator, that means 5.4. Okay, solving for z in this case, we have 40 degrees, we have 8 is the adjacent, and z is the hypotenuse. So in this case, we're going to use cosine. Cosine of 40 degrees is equal to 8 over z times by z on both sides. To cancel it out, we'll get z cosine of 40 is equal to 8. We still need to get z all by itself. So divided by cosine of 40, we get z equals 8 divided by cosine of 40, which if we type this in, this equals 10.4. Finding the missing measurements in this case, since we are finding an angle for both of these, those are 2 of the missing measurements, and then we also need to find the hypotenuse of this. So, starting with finding theta, we have 3 and 10, and in comparison to theta, 3 is the opposite side, so if we set this up as tangent of theta is equal to 3 over 10, since we're finding an angle, we're going to do tangent inverse of the ratio equals theta. And you can type that into a calculator to get that theta equals 16.7 degrees. The opposite thing will happen with alpha. We can do tangent of alpha is equal to opposite of alpha, which is 10 divided by 3. So tangent inverse of 10 divided by 3 equals alpha. And typing that into a calculator, you should get 73.3 degrees. To find the missing side length, we have two of them in a right triangle, so we're going to do Pythagorean theorem. 3 squared plus 10 squared, that equals 9 plus 100, which equals x squared. We'll say that this side is x. So the square root of 109 is equal to x, which equals about 10.4 again. Okay, selecting all the true equations. I'm going to start at the very last one because if we have cosine of any angle, that's going to be equal to sine of 90 minus that same angle. The same thing applies if we have sine of any angle, that's going to be equal to cosine of 90 minus that same angle. So we can see that since these ones in part D are both sines, that won't work. Sine of 37 equals cosine of 53, that works because 37 plus 53 is 90. Tangent does not apply to it. Cosine of 37 equals sine of 53. Same thing. Number 8, a construction company is building a ramp for a parking garage. The plans show one of the ramps to be 20 feet tall. They know that to meet safety code, it has to have an angle measure of 8.5 degrees. How long should the ramp be? So that's finding the hypotenuse, the ramp length. We know that sine of theta has to equal 20 over x, since 20 is the opposite of where theta is. So that means that sine of 8.5 has to equal 20 over x. Multiply both sides by x to get x by itself. And now we have x sine of 8.5 equals 20. Divide by sine of 8.5 on both sides. Now we're going to get x equals 20 divided by the sine of 8.5. Typing that in, it's going to be 135.3 feet. Why are these two triangles similar? We can see that they first have angles that are congruent, the 90-degree angle and then the other angle, and that's all the information we have. So by angle, since both angles are congruent. Two angles in the triangle are congruent. Number 10, why are these two triangles similar? Right here we have a 3, 4, 5 triangle, and then the corresponding sides are also there. We actually could use any of the similarity theorems in this one. I'm going to focus on side on this one because 3 over 12, just matching up its corresponding sides, is equal to 4 over 16, which is equal to 5 over 20. That means that by side, the triangles are similar since all of the sides are proportional. What scale factor or ratio is equal to 5/4? 5 over 4 is on the smaller triangle, and since 5 is on top, 20 is the corresponding part to that. 4 corresponds to 16, so that means that 5 over 4 is equal to 20 over 16 in the other triangle. Sine of A is part of the bigger triangle, so sine of A is equal to 12 over 20, since that's opposite over hypotenuse. Cosine of A equals 16 over 20, and tangent of A is equal to 12 over 16. If cosine of A equals 16 over 20, which means that cosine of A equals 0.8, what's the measure of angle A? So whenever we're trying to find an angle in a trigonometric function, we're going to do our cosine inverse of the ratio. You could also type in 0.8 there. So that means that A is equal to the cosine inverse of 16 over 20, which equals 36.9 degrees. If we have a squared plus b squared equals c squared, what would it look like if we solved for a squared? We would minus b squared on both sides. So now we get a squared equals c squared minus b squared. And that is it. If we have tangent of x equals opposite over adjacent, what would it look like if we solve for the adjacent side? Okay, well, we're going to first get the adjacent out of the denominator. That means we have adjacent times tangent of x is equal to opposite. Divide by tangent of x on both sides. That means we have adjacent equals opposite divided by the tangent of x. Number 13, write an equivalent ratio to AB and then A over Y. So A over B, the matching side to A looks like it is Y, since this is just rotated. And the matching side to B is X. So that means A over B is equal to Y over X. And then similarly, if we have A to Y, that means we have B over X. Okay, the Eiffel Tower is almost 1,100 feet tall. Tom is standing somewhere in Paris looking at the top of the tower. Draw a diagram of Tom and the Eiffel Tower. I'm just going to draw this as a triangle. We have 1,100 feet. And Tom is somewhere looking at the top of it. He's looking up at the top giant. X is the distance that Tom is away from the tower, the base of the tower, and beta is the angle of elevation from Tom to the tower. For this one, an equation that has beta in it that we would use to solve for beta. So I'm going to use tangent since those are the two sides that we have. We have an opposite and adjacent. So 1,100 feet divided by x. Now solve this equation for x. If we know that x is going to be, if we multiply both sides by x, and then if we divide, just like we did above, by tangent of beta, we're going to get x is equal to 1,100 divided by tangent of beta. And last one, now we know that beta is equal to 16 degrees, and how far is he away from the top of the tower? So we're trying to find x. So now we just have to plug beta in for our equation. And if you plug that in, you'll get 3,836.2 feet. And there you go. There is the unit 4 review.